All right, so here we have another technology matrix, and this is energy and transportation. So that's our two by two matrix, and we're supposed to find the output for each sector to find a final demand of 50 and 50. All right, so let's go and plug all this in our calculator. And again, I haven't done anything, so what we're going to do is we're going to do it all kind of from scratch. And so this time we're having a two by two, so we're done there. Now we can go to B. Again, it's a 2 by 2. And now we type in our problem here, which is 0.25, and then 0.25, and zero point 0.4, and zero point 0.2. And so now we can quit that, and let's go back in, and now we can do our C, which is number 3, and we want a 2 by 1, and that was 50/50. Okay. And so we can quit that. So now let's do A minus B, and that's going to give us our I minus M. Now we can take the inverse of that. So that's our inverse. Now we're going to take that times our 3, which is our D. And so this is going to be our X. So X is 105 and 115. So now let's go put that into writing down over here. So it says that X is equal to, and then we had 105, and this is in millions of dollars. And for energy in the first one, and then the other one was 115, so it was 115 million, and this is for transportation. Okay. All right, so that is our x. And again, we found I minus m, and then we found I minus m inverse, and then we took I minus m inverse times d, and that's how we got that. Now, it says discuss the effect on the final demand, which is what this is here, if transportation output in part A is increased by $40 million dollars and energy output remains unchanged. So this is going to stay the same, and we're going to change this to 155 million. All right, so now what we're going to say is X now is going to be equal to 105 and 155. And what we want to do is we want to figure out the effects on the final demand. So what we need to do is now we're going to do demand is equal to I minus M times X. So we're going to take this with the 50 million increase times what I minus M is, and then we're going to figure out what our demand is. All right, so let's go back over here again, and we'll share this screen. All right, so now what we need to do is we need to go edit, and we need to edit our 2 by 1 matrix. And so now we're going to call this our X instead of our D, and then we're going to get out D when we get done. So this is now 105, and it should be 155 here. And so let's quit that. And so now we just have to take matrix 1 minus matrix 2. So that's I minus M times now our D, which, oops, let's quit. All right, let's go back over here, times our D, which is 3, and we get 40 and 82. So that's our demand. So what that says, 4082, is going to be, so that means energy is 40 million in demand. And our other one, which is transportation, is 82 million for the demand. Okay, so before we said it was a demand of 50 million to 50 million, but if we increased our X, which is the output, to 155 million, then that means we can have a $40 million demand for energy and an $82 million demand for transportation. Okay. And so that's what we can do. So we first went one way, got X, and we changed what X the output was to 155. And then we went and said, okay, now what kind of demand is that required to get to this? And we go backwards and we found 40 and $82 million for the demand respectively. All right, so let's stop there.